Welcome to the Explainer. Today, we're jumping right into the heart of Amazon Web Services. We're going to pull back the curtain and see how that massive ecosystem of services actually talks to each other, from the basic languages all the way to the protocols that keep everything humming. All right, let's get into it. I mean, it's a huge question, right? You've got hundreds of services. I'm talking storage, databases, machine learning, you name it, all running in the cloud. So how in the world do they talk to each other? And maybe more importantly, how do our apps join that conversation? It sounds like it should be just impossibly complex, but you'll see it actually boils down to a few key ideas. All right, section 1, the core languages. We're talking the lingua franca of the cloud. And that's exactly it. For any of this to work, everything needs to speak the same language, or at least understand each other. In the cloud, it's no different. AWS basically relies on this powerful combo of an architectural style and a couple of key data formats. This is what makes sure every single service, from S3 to Lambda, can understand each other without a hitch. So first up, we have representational state transfer, or REST. Now, the key thing to get here is that REST isn't a language itself. It's more like an architectural style. A better way to think about it is like, it's the grammar. It's the rules of the road for how all these web services are going to interact. So, whenever you hear a developer talk about making an API call, well, they're almost always doing it within this RESTful architecture. It's the framework that makes all this communication predictable and reliable. Okay, so if REST is the grammar, what do the words actually look like? Well, for a long time, the main answer to that was XML. That's Extensible Markup Language. It basically packages up data using these descriptive tags, which if you've ever seen HTML for a web page, it'll look really familiar. Now, to be fair, it's not always the go-to choice in AWS these days, but you'll definitely still see it around as an option for formatting the messages that are flying back and forth. And that brings us to the new king of the hill, JSON, or JavaScript Object Notation. And trust me, if you work with AWS, you are going to see this everywhere. It's pretty much the default format for most services, and for a simple reason. It's just so darn efficient. JSON is super lightweight, it's easy for us humans to read and write, and it's incredibly fast for machines to parse. That combination has really made it the dominant data format of the modern cloud. All right, section 2, the request journey, or how a message actually gets from point A to point B. So, okay, we've got the architecture, right? That's REST, and we have the data formats, XML and JSON. But how does a message actually get from, say, your application all the way over to an AWS service like S3? What does that whole journey look like in the real world? Believe it or not, it all boils down to this really simple, universal 3-step cycle. Okay, step 1, your application creates the request, right? It formats it in either JSON or XML. Step 2, it packages up that request, adding on the crucial stuff like your security credentials to prove you have permission to do what you're asking. And finally, step 3, it sends that whole package out using a protocol. And that's it. This simple cycle is really the fundamental heartbeat of all AWS communication. Moving on to section 3, securing the conversation, keeping data safe in transit. So that second step we just talked about, packaging with security info, that brings up a super critical point. These requests, they're not just flying around in some private network. They're going across the public internet. So how do we make sure that the data inside them is kept safe and private from prying eyes? Well, the answer lies in the transport protocol. And you have absolutely seen these prefixes in your web browser a million times. You've got HTTP, the standard hypertext transfer protocol. But then you've got HTTPS. That S at the end is the whole ballgame. It stands for secure, and it adds a crucial layer of encryption on top, using something called SSL/TLS. This basically scrambles the data, making it completely unreadable to anyone who might try to snoop on it while it's in transit. And this is a really key point to remember. AWS does technically support both HTTP and HTTPS for communication. But let's be real. For any serious real-world application, HTTPS isn't just a suggestion. It's the standard. It's non-negotiable. It's what ensures that all the conversations between your app and AWS are private and protected from end to end. Okay, section 4 is about going beyond the web with MQTT for communicating with the Internet of Things. So what we've talked about so far makes total sense for a standard web application or a server. But what about the billions of other devices out there? I'm thinking of those tiny little IoT sensors out in a field, or smart home gadgets, or even industrial monitors on a factory floor. They don't have the power or memory of a full server. So how do they talk to the cloud?
For that exact problem, AWS has a specialized protocol called MQTT, which stands for Message Queuing Telemetry Transport. It's designed specifically for what we call constrained devices, things with very little power, not much memory, or a spotty network connection. And here's the cool part. Instead of that typical request and wait model of REST, MQTT uses something called a publish-subscribe model. This is way more efficient for sending tiny, frequent bits of data, like a quick temperature reading or simple, "I'm okay" status update.
And what's really amazing is how integrated this all is within the AWS ecosystem. These little tiny IoT devices, speaking this MQTT language, can directly interact with some of AWS's heaviest hitters. We're talking services like S3 for storage, DynamoDB, Amazon Kinesis for streaming data. They can even trigger an AWS Lambda function or send a message to SNS or SQS. All of this power unlocked for a tiny device, thanks to this one lightweight protocol. All right, final section. Section 5, finding your methods, or how to discover what's possible. So let's recap. We've got REST, we've got JSON, we have HTTPS for security, and even MQTT for IoT. We have all these languages and protocols. This leads to the final and maybe the most practical question for any developer out there. How do you actually know what you can do? What are the available commands, the so-called API methods, for any given service? And this is a really fascinating concept. You see, in a perfect textbook RESTful world, an API might use this principle called HATEOAS. It's a mouthful, but it just means that every response you get from the server would include links telling you exactly what you can do next. It would be totally self-discoverable. Now, AWS isn't quite that, let's say, pure, but the core idea is still there. The list of actions you can take is dynamic. It's context-aware. What you're allowed to do can actually change depending on the service, what permissions you have, or even if you're using a secure connection. And this is precisely why the official AWS documentation is your absolute best friend. It's the essential tool. What it gives you are these things called URI templates. And by studying those templates and the API structure, you basically learn how to build valid requests yourself. So think of it this way. It's less about the API holding your hand and telling you what to do next, and more about you understanding the rules of the game so well that you just know what's possible in any situation. The documentation, it's your map to getting that understanding. So there you have it. We've gone on quite a journey, right? From the core languages of the cloud to the secure protocols that carry all that data and even the specialized dialects for the Internet of Things. What I hope you've seen is that communication in AWS isn't magic. It's a really well-defined system built on these powerful, flexible standards. So the only real question left is, now that you know the language, what are you going to build? I really hope you found this little deep dive into AWS communication helpful. If you did, you know what to do. Go ahead and hit that like button, maybe share it with a friend or a colleague who'd find it useful, and of course, subscribe for more explainers just like this one. Thanks so much for watching.